Check, 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 one. Check, 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 one.
Great. Good evening, everyone. Welcome to the American Philosophical Society and the second of our America's Scientific Revolutionaries lectures supported by the Richard Lounsbury Foundation. My name is Adriana Link, and I'm the Curator of History of Science here at the APS, and I'm really excited to welcome you all this evening for what is sure to be a really timely and exciting conversation with Dr. Marcia McNutt and Dr. Patrick Spiro, the CEO of the APS. Who's new to the APS? Any first-timers? Fantastic. So delighted to welcome you here tonight. So for you, joining us for the first time, the American Philosophical Society was founded by Benjamin Franklin in 1743 for the promotion of useful knowledge. And when we think about useful knowledge in that context, we are in a lot of ways really thinking about the history of science and the application of scientific ideas, engineering, farming, and the kind of innovations that were really foundational to the early republic. Today, the Society continues to be a catalyst for the discovery of new knowledge. Election to membership honors those who have made exceptionally significant contributions to science, the arts and humanities, and public life. The Society promotes research by providing over $1.5 million in research grants a year, especially to younger scholars who need that funding the most. Our library and museum, located right across the street, and our collections and research centers, which include the Center for the History of Science, serve scholars and visitors from across the globe. So if you are unfamiliar with us, please check out our website, which is www.amphilsoc.org, to learn more about who we are, what we do, and about upcoming events like this one. So today's program, as I've mentioned, is part of America's Scientific Revolutionaries, which is a 2-year initiative. So we started this in 2024, around the same time to coincide with the launch of the Center for the History of Science, as a way to highlight the work of lesser-known scientists and physicians who are working in the revolutionary era. So those of you who are in Philadelphia, you know that there's a lot of buzz around the 250th, and it's exciting to be able to tell those stories and revisit some of those well-known events through the lens of science and society. I should say, too, that we have quite a full house online, so welcome to the over 200 people who are registered online. So glad that you chose to be with us this evening. I don't know what the weather is like where you are, but here it's become quite a glorious evening, so thank you also to the folks who are here in person. So inspired by this event, we've been doing these programs around the country, but I'm excited to host this one here in Philadelphia. And so we are here to talk about James Madison. Now, many of you may be thinking, you've heard me mention scientist now a couple of times, and you may be thinking to yourself, wait, how is James Madison a scientist exactly? So most of you probably know him as the 4th President of the United States, the drafter of the Constitution. But Madison, along with Thomas Jefferson, embarked on a lifelong fascination with the sciences, one that would prove really key to the foundations of the early United States. At Jefferson's urging, Madison maintained a weather journal, a meteorological record from his plantation in Montpelier, and you can actually see it in the case over there, where he recorded details about temperature, precipitation, wind speed, even crop cycles, and the birds that were migrating through the area. In 1791, Madison also joined Jefferson on a journey throughout New Jersey, New York, Connecticut, and Vermont, where he met with farmers to learn about the destruction caused by a tiny, tiny little fly that was given the name the Hessian fly because of the vast destruction that it was doing on the crops. So Madison, like Jefferson, advocated for the importance of citizen science as an approach that was not only useful for gathering information about the resources that were located across the continent, but also as a strategy for mobilizing scientific networks in times of crisis. And for that reason in particular, we're quite delighted to welcome Dr. Marcia McNutt, who throughout her career has demonstrated the power of collective scientific work in times of crisis. So with that, please let me introduce Dr. Marcia McNutt. She is a geophysicist and the 22nd president of the National Academy of Sciences. From 2013 to 2016, she was editor-in-chief of Science Journals. She was the director of the U.S. Geological Survey from 2009 to 2013, during which time they responded to a number of major disasters, including the Deepwater Horizon oil spill. For that work, she was awarded the U.S. Coast Guard's Meritorious Service Medal. She is a fellow of numerous associations, including the American Geophysical Union, the Geological Society of America, the American Association for the Advancement of Science, and of course, the American Philosophical Society. She's done many, many other things, which I'm sure she's going to talk about more this evening, and I don't want to over-belabor this introduction. So I will turn it over to Dr. McNutt and to Patrick Spiro for this evening's conversation. So thank you all so much.
Well, thank you, Marcia, for taking the train up to visit us here in Philadelphia from D.C. I know you just had a very busy week last week with the meeting of the National Academy of Sciences. As many of you know, the Philosophical Society had our spring meeting as well, just before that. So I want to start off with talking a little bit about Madison. As Adriana mentioned, Madison was what they would have described as a natural historian in the 18th century. Not a scientist, that word wasn't coined until the first part of the 19th century, a natural historian. And I like to, when people ask me, why do they call themselves that, I'd often say, well, they thought about what a historian does, which is studies the documentary record. They want to document history. In the 18th century, a natural historian wanted to document the environment, the world in which they lived, which really morphed into sciences. But in the 18th century, they took a very ecumenical approach to the environment. And there weren't disciplines that were so clearly defined today, like geology or physics or oceanography and the like. And we see that in Madison's own interest. He observed the climate, and the journal that Adriana mentioned, that was also, correct me if I'm wrong, Adriana, was gifted to us by Dolly Madison. He was also very involved in the exchange of seeds across countries with the idea that there could be discoveries in the environment, new plants or crops that could be introduced to nations around the world to help improve their own situation through greater agricultural produce and new crops. And he was also on this fascinating expedition to New York to study the Hessian fly, this invasive species that was ravaging American wheat. So that leads me, Marcia, to your career, but in a little bit of a roundabout way. So, Marcia, Madison was influenced by his agricultural interest. Even though it was ecumenical, what was driving him was he was a farmer. He was in agriculture. He's in agriculture. He wanted to know how new knowledge could improve the output of farming. You grew up in Minnesota, the land of 10,000 lakes. How does somebody in that environment get interested in the ocean?
So, interestingly enough, if you look at recruitment to the U.S. Navy, Minnesota sends more young men to the Navy proportionally than any other state. So, I'm not sure whether it's because Minnesotans grow up around water and they just spend their life on water, so whether that attracts them, or whether it's because there's just this sense of something far distant, exotic about the ocean. But in my own case, it really wasn't the ocean itself that drew me away from Minnesota, but rather when I was in college, I decided to major in physics because I had a wonderful physics teacher who just so inspired me as a student that I just thought physics was so beautiful, so logical. I loved the fact that there were laws that governed the natural world according to physics. So I went off to college, and as I was about to graduate, I was talking to my advisor there, and he said, well, what are you going to do after you graduate? And I said, I've got this great plan. My best friend and I are going to go be ski bums in Sun Valley. We're going to be bartenders at night, and we're going to ski all day. And, after a gap year or two, then I'll think about what I want to do next. And my advisor goes, oh, no. That's not what you're going to do. If you do that, what will happen is 2 years from now, you will be married to a ski patrolman named Sven, and you will have little babies crawling around your feet, wondering whatever happened to all your dreams. So he said, instead, you need to go to graduate school. And I said, well, my parents still have my sisters in school. They can't pay for me to go to graduate school. He picks up a piece of paper, he hands it across the desk to me, and he says, they won't have to pay. You fill this out, you will get an NSF graduate fellowship, and it will pay for your education. And I said, well, what should I study? Should I go into nuclear physics or astrophysics? He said, no. Those fields have become so large, with so many large teams of scientists, that you will find yourself difficult to make your own name in the business. And he handed me then the first Scientific American article written on plate tectonics. It was the first time that plate tectonics was being exposed to those who were not geophysicists or scientists themselves. And I had taken geology courses and loved them, but I thought they were too ad hoc, too arm-wavy. But I read about plate tectonics and I thought, this is so simple, this is so beautiful, it must be right. And so I immediately decided, since all the plate boundaries were underwater, I had to go study oceans.
Oh, wow. And have you stayed in, have you stayed in touch with this advisor throughout your career?
I did. I stayed in touch with him for many, many years. He died last year at the age of over 100. Wow. But he was an amazing mentor to so many young students who came through his training.
So, you follow his advice. You arrive, I think, at the Scripps Research Institute, where you pursue a PhD in oceanography. And I am an early American historian. I study these three guys over our shoulder. So, reading about your research, I can't speak with any expertise. But one of the things that I was struck is when I thought about what you had to learn and how you had to bring many different disciplines together. So, there's physics, there's the ocean, there's geology, there's chemistry, probably some biology and other sciences that I'm not even aware of that you had to bring together to study plate tectonics and also a whole range of other phenomenon. So can you just tell us a little bit about your research, what you studied and what you discovered?
Yeah, so what I really loved about ocean sciences was that it includes all of the major fields of science. But because ocean scientists go out on ships to study the ocean, they are naturally these collaborative spaces in which on the same expedition you will have physical oceanographers, you will have chemical oceanographers, you have marine biologists, you have marine geologists, marine geophysics, all wanting to study the same part of the world, but from slightly different perspectives. And you learn that the ocean is basically one very large biogeochemical reactor. And that means that in order to do anything in ocean science, you have to be familiar with all the others. So when I first arrived at Scripps, my first year there was spent studying each of the major disciplines. I studied marine biology, I studied marine chemistry, I studied physical oceanography, and I studied marine geology so that you are familiar with the nomenclature of all those fields and basically how they work together to study the oceans.
That's great. So you went on a number of expeditions. Can you take all of us who maybe have never gone on a scientific expedition onto a boat and tell us some of the things that you yourself studied on these expeditions in the same way that Madison went on his expedition with Jefferson to study the Hessian fly?
So the favorite era for me of going to sea was before satellite communications. Because once you leave the dock, you are out there on your own. There's sometimes radio signals you can get, and Occasionally, you can get a very expensive, like $10 a minute phone call somewhere. But the beauty of it is that once you leave the shore, you're on your own. You are a self-contained little microsystem, and you have to count on the people who are with you to make you successful and to overcome any emergencies that happen. I remember on one of my early expeditions, the main instrument I wanted to use broke down. And I had to figure out how to fix it just using whatever, it's sort of like MacGyver, if you've ever seen that show. You have to just use the tools that you have there at hand in order to get everything fixed and working, because the ships cost thousands of dollars a day to run, so you don't want to waste your time out there. You want to get all of the data you can. And we all are supporting the mission of everyone else on the ship, too. So it's a wonderful community. Once we got, further on in the years and there was satellite and internet at sea and all of that, there wasn't this sense anymore that it was us against the ocean. But it was still fun.
Wow. No, it reminds me of a lot that I've read about the impact of the internet and society and how it's changed us as well. And I hesitate to ask this question. I mean it a little tongue-in-cheek, but do you think productivity has gone up or down with the internet on the boat? On the one hand, you can probably transfer data and do a lot of study that you couldn't before, but on the other hand, you probably people can email you for a million different things while you're out at sea.
Yes, generally you try to leave these very dire out-of-office messages that really discourage people from bothering you. But I would say productivity has probably gone up, because the thing about the oceans is we don't know much about them. So you set out and you have a really good idea of what hypothesis you want to test and what you're studying. And you bring along with you the information you think you need in order to interpret what you're going to see. But then once you get out there, everything goes out the window. Oh, wait, I thought that this was because of this, and oh my God, no, it's because of this over here. But I didn't download the right data sets I need to interpret it properly. I didn't download the right background in order to put this into context. And so I think it actually has helped, even though from my own standpoint, I liked the culture prior to the internet.
Yeah. So you mentioned that it was while you were an undergraduate, the first major article came out on plate tectonics. So thinking back on your career from that first article to today, what are some of the ways in which our thinking about plate tectonics have changed?
Yeah. So I think we recognize that plate tectonics was a really good framework for understanding why volcanoes are where they are, why faults, happen in certain places, and why there are earthquakes there, and all of that. But we recognize that it's sort of like, I guess the best analogy of a more modern field would be, we understand that DNA is the building block of life, but yet that doesn't tell us everything we need to know about why we are the way we are, why we're susceptible to what we are. DNA is a good framework, but it doesn't explain everything. And I think it's the same with plate tectonics. It gives us a big picture, but there are so many there's so many geologic events that happen outside the framework of plate tectonics that still need to be understood.
Yeah, can you talk about any promising fields of research that are currently going on?
Oh, my gosh. Yeah. So I would say that people are still trying to understand all of the, there's so much interest right now in how the shallow parts of the Earth relate to the deep parts, and how chemical cycling has happened over the eons. I think the one thing you do say about the way that plate tectonics has affected us is we understand how our experience on this planet is a nanosecond compared to what has actually shaped where we are. And we have to think long term. What I like about this sort of long-term thinking about trying to understand how these areas have evolved over such a long time is that I worry right now that we are being overtaken with short-term thinking. And I almost think everyone should spend some time learning something about the history of the Earth, because it helps us understand that decisions we are making today are going to be impacting this planet for eons. And we may not be around here to even see it anymore on the trajectory we're on. The planet will still be here, but whether we'll be here as its major stewards, I'm not sure.
Wow. Well, that brings me actually to another question I wanted to ask you about, which is we have here Madison's weather diary. He was a student of the climate. He was trying to understand the climate. In fact, in this diary, he documents a major drought that happened in Virginia. And we ourselves have used that to study the drought in Virginia. We were able to digitize that material, share it with others. We were part of a weather data project for 18th century collections like ours, where we were trying to digitize our weather diaries and create a shared repository so that scientists and humanists could use this material in their research. And in the course of your career, and I think Scripps Research Institute was really at the forefront of talking about climate change. And you've seen this idea of climate change, which began really as a theory, science developed around it to study it. And I'd love to hear your perspective, thinking back on the history of climate change, its evolution over time and your place in it.
Well, you know, it was really important that people of Madison's era started collecting climate records. They put in the networks around this country, and of course there were ones in Europe that went back far longer, that actually started documenting in a rigorous, scientifically defensible way how weather changed from day to day. And of course, climate is the sum total, the averaging out of that weather. And it's because of those records that we can actually document without a doubt the effect of the industrial age and the burning of fossil fuels on temperature on this planet. And of course, the temperature is also having its repercussions in terms of rainfall and droughts and everything else. And because of those long records, we can show that prior to the Industrial Revolution, there was noisy data, but basically a very stable climate. The geologic record, which goes back even further than Madison, you know, from ice cores and things like that, show that as the planet was coming out of the last ice age, that sea level was rising, temperature was rising, and then 6,000 years ago, it leveled out. Ice age ended, it leveled out. There's a clear kink in the curve. And it is that kink when civilization begins. Mankind put its roots down on a stable shoreline and stayed there. Built cities, developed agriculture, commerce, everything else that we know and depend on today for civilization. But at the first time in 6,000 years, that plateau is now moving up again. And all of you know human nature. Humans don't like change. And a change of this magnitude, where cities like Baltimore and Miami and
New York.
Yes, New Orleans, which is already underwater. These are all bullseyes right now for what we are doing to the planet.
Well, I was going to get to talking about the future later, but this may be a good opportunity for that. What is your best case scenario for the future when thinking about climate change, and what we may be able to do to perhaps not go back, but contain or control. What's your worst case scenario?
Yeah, I'm not quite so optimistic right now that there is such a thing as a best case scenario. What the problem is there is a delay between releasing the greenhouse gases and actually experiencing the climate effect. So by the time the climate gets so unbearable, the die's already cast. It's going to get worse. There are solutions to this. You've probably heard about carbon capture. And the idea is, if we've dialed up the thermostat by putting all this CO2 and we invest enough money, we could actually start drawing CO2 out of the atmosphere and reducing it and eventually pull down the temperature again. The problem with that is it's very expensive. It is probably 5 to 10 times more expensive to draw a CO2 atom out of the atmosphere than it is to just not release it in the first place. And that's the difficulty we're having right now. We have many solutions to burning fossil fuels. I have my main home's in California, and we installed, well, probably a decade ago, maybe more than that, solar panels on our roof and on our garage. We have 2 electric cars there, and our electric bill is $90 a year. Now, our neighbors who have no solar panels pay $350 a month. So it makes sense to move off fossil fuels economically and financially. But when we have government policies that discourage that and actually provide tax incentives and federal land and offshore land for fossil fuel production, we are just basically going in the wrong direction.
Well, thank you for that, I think. But that reminds me of Madison also, because Madison was a citizen scientist. They didn't have that term in the 18th century, but we do today. And I didn't know what you think the role of everyday Americans are to contribute to the discussion about climate change, or even to help contribute to the science itself through their own work.
Yeah, it's incredible opportunity. So during the days of Madison, and there was a lot of, science was basically done by citizens. There wasn't a profession. And then we sort of strayed away from that as scientists started getting fancy, expensive instruments that were all, intercalibrated perfectly, and we had precise GPS location for every observation and atomic clocks to get the time right. So there wasn't much citizen science, and then came the cell phone. And the cell phone has on it GPS location, it has atomic level time, and it has sensors in it that you can use. So back when I was at the USGS, we put out a app for anyone in the country called Nature's Notebook. And so a person could go out with their cell phone and they could take a picture of the first tulip that's opening up in the spring, or the first leaves that are falling from the tree in their yard. It's all documented photographically, so you know exactly what happened. It's got a date stamp, it's got a time stamp, you know exactly what it is. And we started getting this incredible data set from all over the country of how climate change was making spring earlier and fall later everywhere across the country. And so I had this vision in my mind of, I was frequently, hauled into Congress to testify on well, is this climate change real, or is this just a figment of scientists' imaginations trying to create their own catastrophe? And, with that kind of data, I could say, well, I'm sorry, Congressman, but here are the observations from your constituents showing how much earlier spring is happening and how much later fall is happening over time. Now, do you think your constituents are trying to, create a false crisis? And in fact, I could even show you which ones came from your mother's cell phone.
So you mentioned the U.S. Geological Survey with the Citizen Science Project, and I was hoping you might tell us a little bit more about this institution. It's something we maybe have heard of. I'm founded in the late 19th century to probably conduct surveys, but now it is a much more robust institution. So how many people work there? Where is it located around the country? And on a daily, weekly, monthly basis, what's happening?
So the U.S. Geological Survey is in all 50 states. There are offices everywhere around the country. And what I love about the USGS, it is the only government agency that has no regulatory function. So there is nothing that the USGS is responsible for managing, for policy, unlike, for example, NOAA, which manages fisheries. USGS manages nothing, and so all we do is provide the science for other agencies, Army Corps of Engineers, for the DOE, other organizations, about anything that has to do with American energy resources, mineral resources, biological resources, and water resources is one of our biggest missions. And so what I learned at the USGS, which was so important for becoming Academy president, is it's very important that scientists say, honestly, what the science says, but not what people need to do about it. That is a policy choice, which is responsible for, citizens need to make up their own choice how they're going to use it. Policymakers need to make their own choice. But the data that comes from the USGS, and they have water networks, they have seismic networks, they have biological observing networks that look for endangered species, that look for invasive species, et cetera. So it is widely regarded throughout the government as one of the organizations with the greatest integrity in terms of the quality of the science that comes out. USGS spends a lot of time checking and double-checking every data point to make sure it's the best it can be. When I was there years ago, I think there were about 6,000 or 7,000 employees at the USGS. I'm sure it's shrunk very much today in the last year and a half.
Yeah, and earlier when we were chatting, you were talking to me about the early warning system that was developed
yes.
during your tenure, and how it may be a U.S.-based institution, but in fact, its data has helped save lives around the globe.
So there were two achievements in seismology when I was director there that I was particularly proud of. One is the earthquake early warning system. And people living in Philadelphia don't have to worry about that. But there are many parts of the country where it is actually giving, basically what happens is that earthquake waves move at the speed of sound, but the internet moves at the speed of light. So even after the USGS network has determined that, say, there's been an earthquake on the San Andreas Fault, you still have 30 seconds to get that information to the people of Los Angeles. And in that 30 seconds, you'd be surprised at how much can happen. You can make sure that Elevators stop on a floor rather than between a floor and open the doors so people can get out. You can make sure that the doors on the California aqueduct that bring water from the Central Valley to LA, that those doors close so if there's any rupture in the aqueduct, it's not going to flood the city. You can make sure that bank vaults close their door and lock it, because if a door is open after an earthquake, it won't close again. So all sorts of things can happen. Plus, people can get under a table. They can get outside of a dangerous building. Much can happen. So earthquake early warning was a huge achievement. But another one we had that was wonderful internationally was when a young scientist at the USGS figured out, well, not figured out, he put a lot of work into digitizing all of the building codes around the world. And he put in that same database the population everywhere. He built a network system such that within 2 minutes of an earthquake happening anywhere, we would know we would know what is the likely death toll from that earthquake and what are the likely economic damages, so that we could tell groups that could respond to the crisis whether it was a local event, a regional event, a national event, or an international response. And when that young scientist came up for promotion, I had a letter from the Premier of China and a letter from the head of the International Red Cross telling me how many lives he saved.
There was also one other major, I don't know if you'd call it an accomplishment, but certainly event during your tenure, which was the BP oil spill in the Gulf. What was it like to be at the head of the USGS when that happened, and what was your reaction? What did you do? What resources were you able to redirect towards it?
Yeah. So, the Deepwater oil spill, as tragic as it was, it actually happened at the right time, because when you look at who was in leadership in government at that time, Steve Chu was Secretary of Energy. John Holdren was the President's science advisor. Jane Lubchenco was the head of NOAA, and I was the head of USGS. We all knew each other. And so when the disaster had happened, we weren't, exchanging business cards, trying to get to know each other. And we all worked very hard down in Houston to contain the well, stop the spill, worked very well with BP and the Coast Guard in particular. But what was interesting was everyone wanted to plug that well and stop the oil spill. There was total unity of purpose. But what was somewhat amusing to me was how everyone had their own idea of how to do it. So everyone wanted the same thing to happen, but everyone had different ideas of how to do it. So one idea I had to deal with was all the people writing in suggesting that all we needed to do was stuff a nuclear warhead down the well and explode it, and it would seal the well. And many of my colleagues from the Department of Energy were just itching to open up the nuclear stockpile and do something great with it. Not kill people. No, we're going to be the heroes. We're going to stop an oil spill. And being a geophysicist, I knew quite well that when we put explosions underground, it fractures the rock and actually fluids flow better. It's the whole idea behind fracking, to get more oil out of the ground. So it occurred to me that it was absolutely just as likely that nuclear warhead would make the oil spill problem worse rather than better. But I also knew that there was enough momentum behind this at Department of Energy that it was going to be difficult to derail it just on my opinion. But fortunately, Richard Garwin, who is actually was a member before he sadly passed away of the APS, was one of my consultants down there. And so I talked to Dick Garwin about it, and I said, does this sound like a good idea to you? I mean, they'll listen to you. Maybe they won't listen to me, but they're going to listen to you. And he said, I think I have a solution to your problem. So Dick, who I am guessing never threw anything away in his life, went back and found his college notes from when he was a student at the University of Chicago, and Enrico Fermi was his professor. And he pulled out his handwritten notes in Fermi's voice with all the equations that showed that putting that nuclear warhead down the well would make it worse. And so that didn't happen.
Yeah. And to bring that full circle, Dick Garwin was a very active APS member. In fact, contributed his entire papers to the Philosophical Society.
They're probably there.
Yeah.
You can look for it. Saved us from a worse problem.
Yeah. So and then you moved on to the National Academy of Sciences, which, like the APS, is a learned society. I don't know if you want to share with our audience here who maybe have heard of the National Academy of Sciences, but maybe not, why the NAS was founded, which was Lincoln era, and your role in American science and society today.
Yeah, so the National Academy of Sciences is a young upstart compared to the APS. But we are still proud of our heritage. The way the story goes, though I understand that there have been some liberties taken with the story, is that after the battle between the Monitor and the Merrimack, word got back to Washington that there had been this famous naval battle. They battled to a draw. Neither could sink the other because of the ironcladding. At that time, there were major shipyards in Europe, in Hamburg and in Paris, that were building new wooden warships. They weren't even completed. They just stopped building wooden warships. And so those in Washington, I guess Lincoln was part of this decision, decided that the key to winning the battle space was to have the scientists on his side. So Congress passed a bill establishing the National Academy of Sciences as a non-governmental body that would elect its own members, just like the APS does. But the mission of the Academy would be to be the official advisors to the nation on any topic for which science or the arts, and in those days the arts meant the mechanical arts, so it was engineering, anything in which science or engineering could lead to better outcomes and better public policy for the nation. So that is what we have done since that time. There were two periods in which the Academy particularly grew and rose to quite a bit of prominence. That was World War I and World War II, because science won those wars. And we continue to advise the government. We put out reports, we hold workshops, and our biggest change lately is the fact that back in the time of Lincoln, if it took 2 years to put out a report, well, no one really cared. Nothing moved very fast in those days. But now it does. And the COVID pandemic is a good example. We basically were turning out peer-reviewed advice to the government on how to respond to the pandemic in a matter of 3 or 4 days. And it made a difference.
And how many employees does the NAS have? But you also have, is it about 5,000 members, 3,000 members? And they basically are working more or less for free advising the government.
Yes. Yeah, there are many NAS members here today who know that we call on our members a lot and ask a lot of them. We have Well, prior to the last election, we had about 1,200 employees at the Academy. These employees are mostly PhDs. They are usually younger people, and these are younger people who work at the science policy interface. And they help organize these panels and committees of volunteer scientists from the Academy and also other experts who probably one day will be in the Academy. And they help them organize their work to address questions that come to us to solve. Each academy, there are now 3 academies. So originally it was just the National Academy of Sciences. In the 1960s, we spun out a National Academy of Engineering, and in 2015, the National Academy of Medicine. Now, each academy, our academy is about 2,600 members, but we have about another maybe 500 international members as well.
And, we trace our roots back to Benjamin Franklin right there. If I remember right, the NAS, one of the founders was Franklin's maybe great-great-great-grandson, Alexander Dallas Bache. Do I have that right?
Yes, that is correct. That is correct. And I'm sure that pedigree didn't hurt.
I was going to say, maybe you can trace your lineage further back if you'd like. So my last question, before we open it up to questions, is Madison. There was a recent book written by a political scientist called The Fear of a Setting Sun, and he studied the perceptions that Jefferson, Adams, Washington, Hamilton all had at the end of their life of this republic that they had helped give rise to. And they all were pessimists. They thought they had these grand visions for the republic, but all they saw was corruption, self-interest. All the things that they thought were going to destroy the republic were coming to fruition in their own lifetime. There was one that was an optimist. It was Madison. So I want to ask, as you look to the future of science and society, are you an optimist for the future of science? Are you a pessimist? What are some of the headwinds that you all face, and what are some of the great frontiers that you want to break through?
So, at its basis, science is hope. Science is what gives us hope for the future. Science is, first of all, the only way that we've gotten out of the zero-sum game. That some people can eat more without other people starving. That some people can have more water without other people having to go without. Science has allowed us to prosper in a way that no one would have imagined at the time of Madison. So science is hope, but science is also the best tool we have for foreseeing what the future looks like. Because no matter what your ideology, the laws of science win in the end. And it doesn't matter if you say, oh, climate change is a hoax. I'm sorry, the laws of CO2 win out in the end. It doesn't matter what you think. It matters how the laws of nature work. So I guess I am hopeful that science will continue to lead us to better lives, more hope, to a sustainable future for humans on this planet. But it's really going to take all of us who are scientists to work with people who aren't scientists to help them appreciate how important it is to use this future visioning that we can do with science to make the right decisions today.
Thank you. So I could keep asking questions, but I want to open the floor for a couple, if there are any. Yes, Barry.
Thank you for a fascinating discussion, somewhat terrifying, but fascinating. Last year I read an article, I think in the New York Times, about how the warming of the oceans might be to the detriment of ocean currents and the weather, but I haven't seen anything about that recently. Can you, is that something you can comment on?
Yeah. So a lot of people don't know that it's the oceans that have actually been saving us from the worst impacts of climate change. The oceans have absorbed more than half of the CO2 we've put out, and the oceans are accommodating more warming than is really in the ocean's best interest. So right now, scientists are very concerned that the ocean's ability to absorb CO2 is actually going to start flatlining, and it's not going to continue to absorb the CO2, and therefore we are going to see a quick acceleration of warming as that CO2 stays in the atmosphere. The other downside of the oceans absorbing so much of the heat and so much of the CO2 is it's changing the pH of the oceans. So the oceans are becoming more acidic. Coral reefs all over the world are in dire danger. And I'm sure you've heard the analogy that these coral reefs are the rainforests of the ocean. They have more biodiversity than any other single area of the ocean, and that is all at risk now. And it's also at risk at a time when we haven't completely even studied these systems. There could be novel therapies for cancer or Parkinson's disease or Alzheimer's or whatever lying in these diverse rainforests of the ocean that could be wiped out before we even knew what they were. So yes, it's that New York Times article was dead on, and it's a big problem. There's also concerns about changing the ocean currents. But at its very simplest level, anytime we put more energy into Earth's atmosphere and more energy into the ocean, that energy creates bigger impacts, bigger effects. It creates stronger hurricanes, deadlier tornadoes. It creates deeper droughts, more floods, and we're already seeing that in the climate record. Yeah, sorry about that.
Hi,
Yes.
Marcia.
Andrea, yes.
Yeah, so we're watching, right, the wholesale destruction of U.S. science happen in record time. And, you know, this is coming about because basically the federal government has shredded the compact that it's had with science for a long time, for decades. And I can't help but think that this is really partly due to a breakdown of the relation that science has had with society. And I guess the question is, how do you see us sort of renegotiating that, coming to a healthier compact with all of society?
So, you know, unfortunately, there's not any one thing we can point to. When people ask me about this, you know, assault on science, I say, I think at its root, it's short-term thinking. And because when you go out and survey Americans overwhelmingly support science. They overwhelmingly want the government to invest in more scientific research, to bring new cures, entire new industries, new jobs, new opportunities for people in this country. So they do that, but they don't necessarily put it at the top of their list. So if you go out to someone who doesn't know much about science, they're certainly supportive of science, but if you ask them, well, what's more important to you right now, to have lower fuel prices or more scientific research? They'll say, oh, well, fuel prices are going through the roof. I want lower fuel prices. But, actually what we're delivering for the American public right now is less science and more expensive fuel. So we're not actually doing anything that is helpful. So I think that one thing we could do as scientists is do a better job of showing people how their short-term well-being right now is related to science investments we made a while ago. And the well-being of their children and grandchildren is going to similarly depend on what investments we make now. I love the statement from Harvey Feinberg, who just stepped down recently as the president of the Moore Foundation. And he said, let's do a thought experiment. Let's suppose China had an evil plot for how to destroy American greatness. What would they do that's any different than what's happening right now?
So, Kathleen, for the last question, I might just quickly follow up here at the, we're at the APS, and our headquarters at Philosophical Hall are right next to Independence Hall. That was ground that was gifted to us by the government, and I think it's because at the founding they realized how important science and knowledge was going to be as a pillar to the Republic itself. And that's what we see in this document here. The Hessian fly was ravaging the American countryside. It was could lead to a famine, and the APS, functioning much like the NAS does today, sent out a expedition. It was Thomas Jefferson and James Madison to understand that, to try and address those problems, because they knew it would improve society itself. Kathleen?
Yeah, it's my understanding that when Lincoln and the Congress said they wanted to have a National Academy of Sciences, that they thought they might listen to it. So if we're in an environment in which those people who are supposed to be guiding policy won't ask for the help, and if the help is offered, they don't listen, then what can science and scientists do at the National Academy of Sciences to increase the likelihood that we get the kinds of policies that would be beneficial to all, or more beneficial than they otherwise would be, if they had scientific input?
Thanks for that question, Kathleen. I guess what I'd say is that we are still putting out reports that the government is listening to. For example, we recently, Ellen Leshner, who was the former head of AAAS, chaired a fast-track report on to examine the problem that the regulations on research have grown from 2 in 1990 to more than 100 today. And that researchers who were trained to be scientists are now spending 44% of their research time on paperwork. So the government didn't think they wanted this, but we managed to raise some money to do the report anyway. It is being taken up all over Washington now by these organizations like NIH and DOE, EPA, that recognize, it's in no one's best interest if people are spending a lot of time on unnecessary paperwork. The report didn't assume that anyone was going to remove any regulations, but there are ways to make them much easier to deal with, AI being one good example, and also having the regulation tiered to the risk. Why should a social science survey require the same paperwork as injecting a foreign substance into someone's body? But yet right now they do. So I think we are being listened to, but honestly, I think it is because of vaccines and climate change that is causing government to think that scientists are not on their same page. But when it comes to reports on quantum or AI or any of these other topics like that, they are very welcomed. So, the issue was, back when I had time to do real science, science was a bipartisan issue. In fact, I remember the day when scientists actually wanted Republicans rather than Democrats in Congress, because Democrats wanted to send lots of federal money to social programs, whereas the Republicans didn't want to, and so they gave more money to science. And that has completely changed. I think we have to really work to make science bipartisan again. That's the most important thing we can do.
Great. Well, thank you, Marcia. Thank you all.